Hello folks, this is 2022 May-June paper 2-2 and the question number is 4. This question is concerned with this chapter dynamics as evident from the question here. The first question states, it says state the principle of conservation of momentum. So it is, we can state it as, it states that the total momentum of a system of bodies or objects is constant provided no external force act on them. No external force acts on them. So total momentum of a system of bodies is constant provided no external force acts on them. So that much. Now number B, two balls x and y move along a horizontal frictional surface as shown from above in the figure. So this is the above view, upper view. Ball X has mass 3 kg and a velocity of 4 meter per second and a direction at angle theta to the line AB. Ball Y has mass of 2.5 kg and a velocity of 4.8 meter per second in a direction at angle theta to the line AB, again theta. The two balls collide and stick together. After colliding, the balls have a velocity of 3.7 meter per second along the line AB on the horizontal surface as shown in figure 4.2, like this. By considering the components of the momenta along the line AB, calculate theta. So it has given us idea that we have to consider the components of the momenta along this direction to find theta. So let's find it. So the component of this momentum in this direction will be like, so it is 3.0 into 4.0 into cos of theta. So since this angle is theta here, the component here should be cos theta plus, for this we have this thing and its component will also be like this. It's also again like this. Let us do like this. So it's again theta here, so it should be 2.5 into 4.8 cos of theta equal to, in this direction. Now the mass is added of 3 and 2.5, so it is a 3.0 plus 2.5, then the velocity is 3.7 into 3.7. So here no angle there because it is 0 degree now. So this gives me or I can say 12 cos theta plus 2.5 into 4.8 is also 12. So 12 cos of theta is equal to 5.5 into 3.7, which gives me 24 cos of theta is equal to, this is 5.5 into 3.7 equal to 20.35, which gives me cos of theta is equal to 20.35 by 24, that will be equal to 20.35 divided to 24 equal to, so 0.8479. Lots of other values also which I am not using. So this gives me theta is equal to, so cos inverse answer equal to 32.014 degrees. So it should be simply equal to 32 degrees if I use 2SF only. So the angle theta should be equal to 32 degrees. Now by calculation of their kinetic energies, state and explain whether the collision of the balls is inelastic or perfectly elastic. So we have to identify whether the collision of the balls is elastic or inelastic. So let's do. So see, you can see a child cockroach here, a baby cockroach here. So maybe keen to study physics. So let's do it here. Let us find the kinetic energies in the beginning and in the end as well. So the kinetic energy initial, total kinetic energy initial is equal to 1 by 2 into 3.0 into 4.0 squared plus half mass into v square plus again 1 by 2 into mass is 2.5 into speed is 4.8 meter per second, so 4.8 squared equal to, so it is equal to 0.5 into 3.0 into 4 square plus bracket 0.5 into 2.5 into 4.8 squared bracket close equal to, so it is 52.8 joules. So the initial total kinetic energy is equal to 52.8 joules. The kinetic energy total final is equal to 1 by 2 into the total mass here is 3 plus 2.5. So it is 3.0 plus 2.5, and the speed or velocity is equal to 3.7 squared. So equal to 1.5 into, the sum is 5.5 into 3.7 squared. So that becomes equal to 37.65 joules. So now, whatever be this quantity, it is less than this. So what I can say is, since total final KE is less than total initial KE, so what we must have is the collision is inelastic, and we have to know this from the fact that the two bodies they stick together, collides stick together. So when they stick together, definitely the collision will become inelastic.